So yeah, I just want to echo welcome, say it's great to have everyone here at Brompton. It's great to be here. It's my second time actually talking to a framework gathering. And I really enjoyed attending the event last year in LA and kind of getting to know that term, the pixel people. And I just wanted to frame my talk by talking about, very briefly, about where I see Brompton fitting in. And I kind of see us as, we're sort of the end of the chain. We take your pixels that you've lovingly crafted, that you've maybe been up all night making, and we get them onto the screen and we get them looking as perfect as they can possibly be. So we're sort of the final custodians in the chain, making your pixels the best that they can be. So when I got asked to do this little brief talk, I thought, it's looking like a really nice evening, and 20 minutes on AV over IP, it's not that much time. Could be kind of boring. We could talk about bits and bytes and protocols, and I would enjoy that, but you probably wouldn't. So maybe I shouldn't talk about that. So I called this talk The Good, the Bad, and the Ugly because I want to kind of do a little bit of a tour through where we're actually at with this whole AV over IP thing for our bit of the industry. So there's lots of developments that have happened over the past few decades in AV over IP. But in our bit of the industry, the live events, rental, touring, virtual production, all that good stuff, we're kind of relatively new to it in a big way. And so I'm really going to be talking about 2110 and IPMX for those that know. We'll cover a bit what those are. The replacements for the generally uncompressed standards that we're all used to working. I'm going to use AV over IP, 2110, IPMX, maybe some other words that I just make up pretty interchangeably because I think about them all as sort of one bucket. And so I will try to highlight where there are actual differences, but for the purposes of that, please forgive me, I'm going to use them fairly interchangeably. So the future is now. AV over IP, it's here, it's amazing. Everyone keeps talking about it. And as with many new technologies, lots of slightly crazy things are being said about them. So is it going to solve all our problems like everybody says it is? Well, the answer, obviously, is unfortunately, no, it's not. But it's a very sort of classic thing for a new bit of technology. So, what is wrong with good old HDMI and SDI? They've been serving us well for a lot of years. Why are people so excited? So I'm going to give you first a few examples of reasons that people say they are excited which are incorrect. So it is a very common misconception that 2110 systems are going to be lower latency. What does this mean? Well, who knows, because it's complete nonsense. We're still going to be working in video in frames. There isn't, in most 2110 systems, there isn't going to be a meaningful difference in the number of frames that it takes to get from end to end to the system. Because we're aligned on those frame boundaries, we get faster interfaces. They might allow us to do things, but generally, it's not going to be. So it's not really a good reason to think that that's something that's going to come along. In fact, I would go as far as to say, because I'm feeling controversial, that especially in the early systems, it's likely that your latency is actually going to increase. So there's probably going to be a bit more copying around going on as people get to grips with things. The systems aren't going to be as well optimized, they're not going to be as well tuned, so your latency might even go up. So latency is off the table. And the other one that I like to throw out there is EDIDs, the bane of everyone's life. So is AV over IP going to solve the problem with EDIDs? Well, the answer is yes, because it just gets rid of them completely. But there is a reason why we have EDIDs, I think. And so we might need something to do the job that EDIDs were doing. So yes, it's going to get rid of our EDID pane and replace it with some other pane that we don't even know what it is yet. So it's pretty bad, really, to be honest. Maybe we should just give up. No, so I'm being pretty down on AV over IP. So what is actually exciting about it? Why should we all care? So to talk about this, I want to sort of start with a kind of, I guess what I'd say a sort of standard system block diagram that we might encounter on a relatively large show. So in the middle, we would often start off with some kind of sync source that's outputting our standard bi-level, tri-level kind of analog sync. We then might have a camera system. So we've got some cameras, some switches. Often there's an SDI matrix involved somewhere there. And this is very much the SDI world. So it's a kind of SMPTE fixed, refresh rates, resolutions, relatively constrained. And SDI is actually really good at doing what it does. It's designed for us. It's designed for that pro video market, and it's great. But it's just quite inflexible. And then in our pipeline, we might go into some kind of media server. Maybe there's a presentation switcher doing some chopping of the video. We might go into an HDMI matrix, and then we might hit our display. So that's the other half of our video world, if you like, where we're in this HDMI or DisplayPort land. And HDMI DisplayPort, awesome, they're really flexible, but they kind of weren't designed for us. We're sort of using them for something they weren't originally for, and so that causes us other problems, even to the point of the connector is not ideal for a lot of our applications. It's not locking for something that's show critical. The fact it can just fall out is not ideal. So the real magic of the 2110 IPMX AV over IP system is that it evolves our block diagram to look like this. And now, instead of that, these two halves of the system, our SDI world and our HDMI world, we're all in one world. And that opens up all sorts of really interesting opportunities. It does simplify things to some extent, like we've got rid of our matrices, but we've replaced them with other complicated things that I'm going to talk about in a little bit. So it isn't really making our system, hugely simpler, but what it's doing is it's making all our devices really interoperable in a really easy way. You'll notice that on this diagram, I've been at pains to put all my arrows in this case as going both directions. And that's one of the magical things about using Ethernet, is by default, your links are bidirectional. So that means that a device is no longer just a receiver or a transmitter. We can take both of those bits of functionality, we get them from the same interface, and so lots of devices that historically were only transmitters can suddenly become receivers, and that opens up interesting workflows. Sync is now part of that same network, which is interesting. It maybe simplifies some things, but again, the real magic of this is it gives us the ability to add frame synchronized metadata relatively easily into the stream, so it produces this sort of environment where we can extend things relatively easily. So let's just give an example of that. Let's say, for example, we've got one of these relatively complicated setups. We're doing IMAG, and it's going through a media server, and we're cropping, and we're putting some kind of crazy mask over it. Well, wouldn't it be really awesome if we could get the program output, the final thing from the media server, and send it back to our camera operator so they could actually see what they're framing to? Well, in this environment, that would be HDMI. We'd have to convert it back. We'd have to somehow get it back into our old SDI world. And that would be really annoying, especially if somebody just asked us to do it 5 minutes before the gig started. In a 2110 world, when we're all in the same kind of universe, we're not got all these different media going around, that becomes super easy. And that is a really interesting piece of feedback that we've been hearing from people starting to deploy these early networks, is that once you get into that 2110 world, it's actually quite nice and easy and flexible, and the pain keeps coming when you have to keep converting back because most devices haven't got there. So it is actually really interesting, and I think it's in this sort of interoperability and the ability to build things on top of that network, which is a very flexible thing, that is actually the real magic of 2110 and what you should actually be excited about. So one of the things that I've removed from this diagram is these matrices. So these are a relatively important part of all our workflows, being able to switch and pick what you're seeing at different points. And one of the other clever things about 2110 is our network switch essentially becomes a matrix. And we shouldn't read too far into this because it doesn't give us some of the same guarantees that a traditional matrix would do in terms of particularly what happens around the frame boundaries. But it is very powerful, and it is a highlight of the technology. So because I also love a bit of Jeopardy, I'm going to attempt a live demo of 2110 with this matrix switching actually happening. So, apparently I have to look. Okay, I'm going to have to go out of here. Okay, stand by. I have to end my show. Hopefully OS X will switch back to mirroring. It did. Look at that. Okay, cool. So on the end of our 2110 chain, we've got a beautiful video wall from Brompton Technology. Please regard. So what we've got over here is a little setup because it's quite nice to see this in action, and I'm going to run through it relatively briefly. But please do come and find some of the people from Brompton if you want to see this in a bit more detail and what's going on. So what we've got, if I switch, is we've got two. We're actually doing the classic thing that I said was going to be really annoying, which was generating baseband video using SDI, in fact. Turning it into 2110, sending it over our 2110 network, and then getting it out again to display. But it's interesting to see how this works. So we've got 3 boxes here. 2 of them are SDI receivers, and one is an HDMI transmitter. And this is actually a little visual representation of what's going on in this network. You can see our 3 boxes, and you can see at the moment I've got our nice mystery box HDR content. It's connected to our Brompton S8, and it's outputting, and we can see it over here. So these are all being discovered by the management protocol that's kind of built on top of these AV over IP protocols called NMOS. So it can discover all the devices, and it's going to allow us to configure them. So the very cool thing which we can do is we can just come over here and click. This essentially looks very much like a standard matrix. And if I do this, it will switch to our other content. So we've just used our network switch as a matrix. We've told our S8 to unsubscribe from the stream that's coming from one of our transmitters and subscribe to the new one. And it happens pretty seamlessly as you'd expect from a matrix. So it's pretty cool and it does work. The kind of caveat of this is really that exactly how good this switch is incredibly dependent on many factors, mainly the receiver devices involved. So your mileage may to some extent vary, and this is also something we've been hearing from early users of this technology, that some devices do a really good job of, they essentially can hold the frame while they're doing their stream swap, and that looks quite clean. Some devices take a long time, maybe don't do something so elegant. But it's pretty cool when you see it actually in action. We are switching between our 2 feeds exactly like a matrix, and there is no matrix involved, there is just a network switch. So that's a very quick live demo. As I said, please come over, and if you'd like to see the setup and prove to yourself that there isn't a matrix hidden here, then please do come. So that was the demo. That was some stuff about what it's going to, the basics of 2110 and why I think it's kind of magical. So let's say you want to build an AV over IP system using probably IPMX or 2110. Today, what do you need to think about? What are the interesting problems you might run into? I'm not going to tell you what the solutions are because I don't know what they are. But these are some of the questions that you might want to ask, and I'm just going to black this out so that it isn't quite so distracting. So, 2110 and IPMX. These are probably the standards that you're going to hear about the most. And it has to be said, the array of options at the moment is a bit confusing. 2110 is kind of the base standard on which things are built. IPMX is a superset of 2110. 2110 kind of came out of the broadcast industry. It was very much designed as the successor to SDI. 24G and 48G SDI seemed like a bit of a crazy idea, so they went and did something else. And IPMX has come along, and they're trying to extend the standard to be more applicable to a wider range of environments, particularly Pro AV. The term Pro AV is so general that I'm not sure it really means anything, but that's sort of what they're saying. On top of the 2110 stack came this thing called NMOS, and that's about adding control and discovery, so being able to actually find things on the network and then remotely configure them. And 2110 does not mandate NMOS, but IPMX does. Very clear. So yeah, there's definitely quite a lot to go on in terms of like the extension of options, standardization, and people actually figuring out what means what. There's also these things called SDPs that keep flying around. So that stands for Session Description Protocol, and that's what NMOS actually uses, but you can use manually to move your descriptions about streams around. So you can get a SDP from a transmitter, give it to your receiver, and then it will know how to get it. So the options are quite confusing. There's lots of acronyms. It's starting to come together, but there's plenty to learn there. Networking. So yes, you got rid of your matrix, fantastic, and you replaced it with a very expensive network switch that you don't know how to use. So we're all going to learn a lot about networking, and I think that I know quite a lot about networking, and I think this networking is quite crazy. So there's lots of basic things that you need to figure out, like how much bandwidth do I need? You know, how I want to send 4K video at 60 frames a second at 444. How much bandwidth do I need? How big a network switch do I need to buy? It gets more subtle. How much bandwidth can the switch fabric take? So can I fully use every single port in both directions, and will that still work? That's not necessarily the case. There are all these fun things like QoS, quality of service, so the ability for the network switch to decide that a packet is more important than another packet and for it to skip the queue. So these are all some things we're going to get all figure out together. It's definitely an area where knowledge is, there's some very, very experienced, very good networking people in the entertainment industry that do awesome stuff, but it's something that generally, you know, if you were used to plugging into a matrix, this is pretty different. PTP. So, we got rid of analog sync, fantastic, don't have to run a cable for that. What do we have instead? Well, we have this thing called PTP. So PTP stands for Precision Timing Protocol. It's the way that we embed that synchronization information in the network. So in a large PTP network, you probably need a thing called a grandmaster, the special box that's kind of like your Avert SPG or something that you were using to generate your legacy sync. But do you actually need one for your setup? Well, it's quite unclear. Probably depends whether you're doing 2110 or IPMX. IPMX is a bit more flexible. If you've got a camera, you probably do need one. So you've got to kind of get all this stuff figured out. Interoperability. So as I said at the start of this section, things are changing pretty quickly. There's a lot going on. And what we're seeing is that devices coming from a kind of broadcast background are relatively tightly defined on what they're trying to achieve, and they generally do it. But devices that are trying to be a bit more general and maybe do some of the more flexible things that we'd all like to do, like maybe custom resolutions, for example, generally don't have very good interoperability yet. So that's a big thing that's going to change, with IPMX really helping to push that forward. A lot of what's been implemented up till now is SDI in inverted commas. So a lot of devices do 422 only, and standard refresh rates and resolutions. So it is, again, the flexibility of this, the magic of this flexible network is going to come, but it isn't quite there, and a lot of what's been implemented is kind of pseudo SDI capabilities. So again, one to watch out for. Compression. So compression is a big topic. Unlike where we had, you know, HDMI, and we had some generational increases, but they were relatively sort of static in terms of what was the best at a certain time. When we come to 2110, video over IP, we've got a whole load of options. We could use all sorts of different data rates, different bandwidths. So we could use 1 gig, 10 gig, 25 gig, 50, 100, 400, 800. You know, there's all sorts of options. And one of the things we need to do is we need to actually look at those media options in terms of cost. And when you do that, you immediately say, oh, I wonder if we could compress it a bit so we can get it into 10 gig Ethernet. Thanks, Blackmagic. So there are a lot of codecs flying around. There are some standard ones, JPEG XS, being talked about a lot as something people are going to standardize on. But unfortunately, because of this, the sort of flexible nature of it, it means there are a lot of choices, and we need to come together, shall we say, as an industry to make sensible choices. And finally, cost. So at the moment, there is quite a lot of price inflation going on in this new tech. And that, to be fair, that's completely reasonable. Lots of companies are spending a lot of money to develop this, but it is meaning that a lot of solutions are very expensive and not terribly cost effective. Things are definitely going in the right direction here, but if you were building a 2110 system today, you might be surprised at how expensive some of the equivalent components still are. You know, things like those 100 gig network switches, they're pretty expensive. Again, their prices are coming down, and so it's definitely going in a good direction, but it is still expensive. So that's all I've got for you for today. I have no idea where I am in my time. So I guess I could answer a few questions if people have them, or we can crack on to talk about the wonderful world of AI. But thanks for listening.